exposure to actually solving differential equations. So here we have a linear differential equation, t squared y prime plus 2ty is equal to t. We're going to stare at it for a couple minutes and then notice something peculiar about the left-hand side. It looks like this guy is the direct result of applying a product rule to something. Okay? So it looks like I took t squared times y and I just derived this. Because when I do that, out pops a t squared times y prime plus a 2t times y, right? F prime g plus g prime f. So this makes our job a whole lot easier because we know how to integrate a derivative. It's just itself, right? If we integrate both sides here, on the left-hand side we get t squared times y, and on the right-hand side we get t squared over 2 plus c. And you got to make sure you actually put the c here because unlike Calc 2 here, it actually matters. You'll see. So now all I got to do is just solve for my y. Well, I can divide both sides by t squared, and I'll get 1/2 here and a c over t squared over here, and that's it. I'm done. So that was really easy. What we're interested in knowing is whether this process can be done for any linear differential equation, and the answer is yes, provided that this thing is actually the direct result of applying product rule to something. Well, that's not going to be the case in most differential or linear differential equations. We have to make it such that it looks like it just went through the product rule. So that's where the process of introducing what's called an integrating factor comes from. And in order to find the integrating factor, all you got to do is put the equation in standard form. Remember, it's when y prime doesn't have any coefficients. It's just y prime. It's by itself. And then you find the integrating factor simply by taking the integral of p, which is the coefficient of y, and putting it in a exponential. So you're just saying e raised to the integral of p. Okay? Once you find your integrating factor, all you got to do is multiply the whole equation by the integrating factor, and you end up right here. And all you got to do is just basically rewrite the equation and integrate the right side and basically read off your answer. Okay, so let's go ahead and do an example and see how this actually works out. So we got xy prime minus 2y is equal to x squared. So first, before we do anything with integrating factors, as always, you should look at it and see whether it is a direct result of a product rule itself. So for this to be a result of the product rule, this has to be the derivative of this, and this has to be the derivative of this. Well, y prime is the derivative of y, but 2 is not the derivative of x. So, or rather, minus 2 is not the derivative of x. So we're out of luck. So we actually have to find the integrating factor and put it in there. So how do we find the integrating factor? Well, first we have to put it in a standard form. So let's go ahead and do it. So I'm going to divide both sides by x. I'm going to get y prime minus 2 over x. Y is equal to x. All right. So then my integrating factor is going to be e to the integral of minus 2x, 2 over x dx. Do not forget the minus sign. It's very important. So now I'm going to integrate that. It's going to be e to the minus 2 ln of x. So now you've technically found your integrating factor, and you could proceed just with e to the minus 2 ln of x. But it's going to make your life really hard because this is a very sort of a complicated integrating factor. What I'm going to notice is the fact that I have an ln here and an e here. And I'm going to try to make them cancel each other out by taking the minus 2 inside the ln function using my log properties. So I can say this is the same thing as e to the ln of x to the minus 2. And then the e and the ln cancel each other out. And all I got is 1 over x squared, or x to the minus 2. Right? If you aren't sure about that part, review it and review your log properties. So then what we're going to do is multiply that integrating factor by the whole equation. Now, you're going to be dealing with your equation in standard form, so you really do not care about this guy anymore. Anything you're going to do to your equation in standard form. So we got 1 over x squared times y prime minus 2 over x to the third times y is equal to 1 over x. Just to check, to make sure this is actually the direct result of a product rule, y prime is the derivative of y, and minus 2 over x to the third is the derivative of x, 1 over x squared. You can work it out and see. But so we can rewrite this as d dx of 1 over x squared times y. Right, those are my two functions, y and 1 over x squared, which is equal to 1 over x. So now I'm going to go ahead and integrate both sides. I'm going to get 1 over x squared times y on the left side. And on the right-hand side, I'm just going to get ln of absolute value of x. Not quite, plus c. Remember, from now on, your plus c's actually matter. Okay, so do not forget them. So now I'm going to solve for y. Y of x is equal to x squared times ln of x plus x squared times c. Okay? And that's basically your answer. And as you can see, the c isn't by himself. He's multiplied by an x squared. So you're not going to just be able to add a c, slap it on at the end, and you don't have the luxury of just forgetting about it and just adding it at the end. So don't think you do. So as you can see, it's not hard. It's a little involved, and there are places where you can make mistakes. But the number one thing to sort of keep in the back of your mind is, unless your integrating factor is as simple as it's going to be, this whole process could be very, very tedious. So be careful when you're deriving your integrating factor. Make sure it's as simple as it can possibly be. And besides that, the whole process is very straightforward, and just be careful with your algebra. And there you have it.